Good morning, everyone. Today, I'd like to continue talk about the Zksync Era. This time, we're going to talk about how we can claim field deposit. In last lecture, we talking about how we can deposit a token from L1 to L2, but all we can do is what we do on L1. If it's successful or not, still on the transaction on L2. So what about if L2 fail? Then basically we need to claim the deposit, which is the token we put on L1. So this is what we call claim field deposit. There are three variants for this operation. And we're going to talk about each one. They are actually pretty similar to each other. Very much, let's look at the first one first. So the first one is for the classic one, which we do from the LE ERC20 bridge, which is mainly serve the purpose of claim field deposit from Era. So what is Era? Era is one of the main chain from Zksync. Now, Zksync have many other chains, but Era still remain the first chain, the first bomb. So it's still very important. So this is more like a legacy chain, but I think Era will remain one of the most important chain in Zksync. So here you can see you start the function from L1 ERC20 bridge, which is going to call nullifier. Okay, so nullifier is actually a new name, but actually many of the functionality is from the traditional shared bridge, which is now called L1 asset router. So you can consider L1 or the shared bridge is split into two now. One is called L1 asset router, and the other is called L1 nullifier. As the name suggests, nullifier is more for the field. I think it's more for the claim field deposit because you want to nullify a transaction that's submitted earlier. So claim field deposit legacy ERC20 bridge is going to be called. As the name suggests, this is only for claim deposit that you deposit into ERA chain, okay? Which consists of two branches, basically. The first branch is make sure the transaction indeed failed on L2. And then the second is going to focus on either do the transfer back to the user or going to mint, depends on if it's going to be bridge mint tokens. Okay, so let's look at this one, and then the rest of two variants is going to be very easy to follow. So let's go to the code over here. So the first one is claim. Let's look at it with the claim field deposit. Is right here. So the first thing is you have to retrieve the previous amount that we saved for this depositor. Okay, so it's going to be for the token for the transaction hash. So it's very specific for this sender, for this triple. So this is only, so this function is only can retrieve for a particular token and for a particular transaction. Okay, and so there you get this amount, and then you use that as argument and call the claim field deposit legacy ERC20 bridge. Okay, and then over here we're going to delete it. Okay, because after you claim it, you have to delete it. And then the next thing is we are going to call this legacy, which is only from ERA20, as you can see. Let's go to call it. Oh, it's called a nullifier directory. Sorry. So call a nullifier directory, which is over here. As you can see, it's going to be using the ERA chain ID, which I believe is 234 or something. But in this test, we use it's like 9, I believe. Okay, and then one other thing I want to point out is it's going to call two functions. One is to verify the transaction indeed failed, and the other one is going to do a transfer. Okay, and keep in mind over here there are two things I want to point to your attention. One is this flag is going to be true, which this flag means check in legacy breach, because this is legacy breach means, so this true means it's already checked over here. It's already checked over here. You see, we trying to check the amount over here. If amount is equal to 0, we are not going to remove it. And then after we claim, it's going to delete it, so it cannot double claim. So that means double claim is prevented in the L1 ERC breach already. So that this flag, I guess, means you don't need to, worry about double claim inside this function anymore. And the other thing you have to watch out is it's only claimed from EIA chain 80. Okay, same over here, EIA chain 80. So it's very specific. Let's look at the first one first. I think this is the most important function today, probably. It's called verify transfer over here. Okay, here we go. So now we know this is actually check, this is actually true. And then it's going to call the breach hub proof L1 to L2. So it's actually through the breach hub. I want to show you the over here. So through the breach hub over here, eventually it's going to call the ZK chain, basically the ERA chain, and the same the proof L1 to L2 transaction status. So I'm now going to go to a detail over here. Basically, this is just going to check the status of the transaction and make sure the Merkle root or whatever verification there to show that the status of the transaction indeed failed. So let's say this is successful. Okay. So if that's successful, then if the proof valid is false, then we are going to revert, means we don't have the appropriate proof. Okay. Otherwise, we're going to do some additional check, basically, because this is this check is always going to be true, even you clean again. So it's like view only. So we need to have some mechanism to make sure we don't do a double claim over here. So the first thing is we're going to check if this is pre-shared breach deposit on error. And then combine this flag, we are able to check either we can check deposit here, or we already, so either this one or this one. Okay. So right now we already know for the legacy, this check-in legacy breach is already true. Okay. So that simply means it's going to be rely on the this flag. Okay. Rely on this flag. So so this is going to be false now. So it depends on this is true or false to decide if we are going to check here or not. Okay. So basically, if the test is a pre-shared breach deposit on error, means this is comparing the block number and so on. So that means it's an older deposit. Then we do have to we are not going to check over here. Otherwise, look at this negation. Otherwise, we have to check here as well. Okay, so let's say we're going to check here. So this is the real flag to indicate if we need to check here or not. There are only two cases basically. The first case is this is a false. Check the in legacy breach is false. So that means it's not checked yet. So if it's not checked yet, that means This is already false, so then this flag is going to be true. So then we have to check over here because this means the input means it's not checked yet. So that's case one. Case two is, although this is already checked, the checking legacy breach is already checked, but this is still true. So that means is share breach deposit error is still false. Okay. So that means it's not before the error. It's a new deposit. It's after the upgrade, basically. So in that case, if after the upgrade, we have to check here for sure. Okay. We have to check here for sure. So how it's going to be checked? It's actually checking two ways. The first one is checking if it's a legacy transaction hash. If you check legacy hash, you match over here, then we skip. Otherwise, we have to do one more check. See if it's going to be satisfying the new encode version. So either match this or match this, then we are fine. Okay. So if we need to check, but none of these two match, then it's going to fail. Probably means it's a double claim or error. Okay. Otherwise, we are going to clear it up so that we don't have double claim. Okay. So so that's the let me go back over here. And the other one is we're simply going to call the asset router breach recover field transfer. So let's go there too. I think I messed up this L1. Let me open this again. Bridge recover. Okay. Bridge. Okay, right here. So bridge recover. Okay, so it's going to call bridge recover field transfer. Okay. So here we go. Bridge recover field transfer is going to call bridge recover field transfer. So it's actually a wrapper. Okay, it's calling L1 as a router, but bridge recover field transfer is going to call the native vault bridge recover field transfer. So it's simply a wrapper. So we have to go to the L1 native vault over here. Okay, here we go. So it's going to get L1 token. The first thing you do is handle chain balance chain balance decrease, and we already talked about chain balance increase. It's pretty similar for two cases. The first case, if it's a native token, we are going to decrease it. The other case is the asset ID is not from the chain ID. Okay, so that simply means this token in this case is from L1, not from L2. So it's not equal to 9. So that means we have to decrease it. Okay, And before we decrease, we also double check to prevent underflow. So otherwise, we modify the balance, chain balance for this particular asset. After we have handling the chain balance, then the next thing is we have three cases. The first one is it's Ethereum, and we're going to send the Ethereum back to the receiver, the deposit sender. Otherwise, the second case is we are going to just transfer the token if the original chain ID, if the token is from this L1, okay, originally. Otherwise, we are simply going to mint it, calling the L1 token bridge main means this is a bridge, a standard token that created by Zksync in the first place. Otherwise, we are going to say we don't recognize it. So that's pretty easy explanation for how we claim the failed deposit. Okay. The second variant is going to be pretty similar, but this one, instead of claim legacy, it's going to allow for claim, I think both. Okay. So especially for the new one. So let's look at this. It's start from asset router. So it's start from asset router over here. Claim failed deposit. As you can see over here, it doesn't just have to ERA chain. It could be any chain. So this is more general. You can think of that way. And then in addition, it's just calling the nullifier. So it's just a wrapper. You could, I guess, you can just call the nullifier directory over here. I don't see any authorization, so you can call either way, and it's going to work. So it's going to get the asset ID because you provide it's just token. And then in addition, it's going to prepare the asset data, which is encoding amount and the address 0. You don't need the address over here. And then we call this. But this time we use this as a false because we are assuming this is not necessarily checked in legacy. Okay. And then this one is the same, except over here, it's not ERA chain. It's going to be ERA chain ID. So if we look at these all over again, just to cover the case of a false. So that means this is a false already. So we don't check in legacy breach. So we want to look at this flag over here. So that means so it's a simple claim failed deposit nullifier. Let me just double check claim failed deposit. So it's a false, right? If it's a false, then that means I have to check inside here because you can consider this false means it's not checked yet. Okay, so let's do that identify. So again, this is a false. So that false simply means this flag is going to be true, okay, regardless of this flag. We don't need to worry about this flag. This is already true. We have to check it. That's the case 1. Okay. So the case 1, it's true. And then we're going to match one of these. Okay. So so the first case is a legacy match. The second case is the new match. So it's going to be matched one way or the other. All right. So that's the I believe that's the second deposit. It's pretty similar, except over here, like we said, it's going to be set flag true. And then I don't need to explain the rest of that anymore. Let's look at deposit 3 and see if we have anything new to say out here. Yes, we do. So the third case is you can call bridge card failed transfer on L1 nullifier. So it'll be bridge recover right over here. And it's just calling to function verify and bridge. If you don't see any difference between this one and the claim failed deposit, so to see this better, to see what is the main difference exactly. I copy both function out. So if you compare these two functions, actually they are very much the same, except the argument is slightly different. So the claim failed deposit, you provide the token, and then so you don't provide SID, so you have to calculate SID by calling this function. The other thing is the claim failed deposit don't have the asset data as the input. So in the same way, the asset data you have to calculate yourself too over here. Otherwise, from here all the way here, it's exactly the same as this one, because this one already provide asset ID in the input, already provide asset ID in the input. So that means these two functions, I think, it's identical, very much, just the variance. So I don't think it's significant. All right. So I think that cover all the 3 variants. I hope it's going to be helpful to claim failed deposit. So thank you so much. Have a nice day.